From tropical rainforests to deserts, the Earth's surface is shaped by the action of running water. As raindrops fall or snow begins to melt, some of the water sinks into the ground and through the process of infiltration eventually adds to the groundwater supply. Some rain or snow falls directly onto water surfaces as channel precipitation. The rest of the water flows from higher to lower ground under the pull of gravity. Runoff begins as overland flow after the ground has become saturated. This runoff may spread into a sheet of water for short distances, then divide into rills and rivulets in its course toward lower ground. In areas with sparse vegetation or easily eroded soil, the rills and rivulets combine into larger channels called gullies. Eventually, the overland flow either sinks into the ground or finds its way into a stream. A stream is a flow of water normally confined to a well-defined channel. Each stream has a source, or point of origin, and a mouth, or endpoint, where it flows into another stream, into a basin of interior drainage, or into the sea. A stream's size at any given point along its course can be measured in terms of discharge. Discharge is the volume of water flowing past a particular point in a given period of time. It is expressed in cubic meters or cubic feet per second. The amount of discharge often varies greatly from season to season and from year to year, depending on amounts of precipitation. Most streams in humid regions are perennial. This means that water flows in their channels throughout the year. Most streams in desert regions flow only during and shortly after rains. These are called ephemeral streams, from a Greek word for short-lived. A few large rivers, such as the Colorado, the Indus, and the Nile, have enough water in their channels when they reach dry regions that they maintain a perennial flow across the deserts. These are called exotic streams because they originate in well-watered areas far from the deserts through which they flow. Streams vary from tiny trickles that drain very small areas to mighty rivers that drain enormous regions. Various terms are used locally to describe streams of different sizes and flow patterns. A river, for example, is thought of as a large stream, generally with several smaller tributary streams feeding it. Small streams may be called brooks or creeks, depending on local usage. The word bayou is used in Louisiana for sluggish streams, some of which flow along old channels of the Mississippi River. In some regions, a fast-flowing mountain stream is called a torrent. None of these terms are precise, however, so geoscientists distinguish between orders of streams. A first-order stream has no tributaries. A second-order stream has only first-order streams as tributaries. A third-order stream is formed when two second-order streams join waters, and so on. There are far more low-order streams than high-order streams. In the United States, for example, there are approximately 1.5 million first-order streams, about 4,200 fifth-order streams, but only one 10th-order stream, the Mississippi River. In addition to being more numerous, low-order streams are generally shorter and have steeper gradients than high-order streams. Low-order streams also drain smaller areas. As defined by geoscientists, each stream has its own drainage basin, or area from which it transports water. This basin is bounded by a drainage divide of higher ground that separates one stream valley from another. The drainage basin, or watershed, of a first-order stream is composed only of the valley bottom and sides that drain into that particular stream. The drainage basin of a major river, however, includes the drainage basins of all of its tributaries. Consequently, the higher the order of the stream, the larger the area that is drained by the stream and its tributaries. A typical first-order stream in North America drains about 2.5 square kilometers, whereas the Mississippi and its tributaries drain 320 million square kilometers. A stream system is composed of all the streams that join in a drainage network to carry water from a drainage basin or watershed. A majority of stream systems eventually pour their waters into the oceans. A few, however, terminate in basins of interior drainage. These may contain landlocked lakes such as Utah's Great Salt Lake, or be marked by extensive salt flats, where waters of ephemeral lakes have evaporated in the desert sun. In all cases, however, the water flowing through a stream system seeks the path of least resistance and changes the landscape as it does so.